Welcome friends, please remember on this channel I usually post more advanced or abstract or non-routine math videos, so if you're into that, you should consider subscribing. So I'm going to show you a way to think about parametric equations. I'm going to draw an axis here. So what is this? This is going to be called t. And then here, I'm going to draw another axis, and this one I'm going to call x. Well, it's really like x of t. And then perpendicular, I'm going to draw y, which really is y of t right here. So this is y of t. Using this kind of construction, you can visualize the whole process, for example, of taking a parametric derivative. What I mean is the following. Imagine that I count off, say, along this axis right here, like this is 1 unit, so 1 t. Okay, and then what I'm gonna do is I'm gonna basically take this and I'm just gonna keep that same length. So we've got to make sure that that's true, and then turn it like 90 degrees if possible, and then basically stack it up this way. So that's 2. Let me move this into position a little better. Now connect with a line, and what this then represents is y is equal to 2t. So within this ty plane, you can visualize y against t as this line. This could also be done with curves like t squared or whatever. I'm just going with the linear ones for the sake of simplicity. Now remember that this right here, this is equal to 2. And down here, we have 1 unit along the t-axis. Now let's repeat something similar for a line in the tx plane. So when I do that one, let's see, let's do it in a different color here. I'm going to proceed as follows. Again, it's going to be 1 unit this way, so 1t. But then I'm going to count by, say, 1, 2. Okay, so try to make these even, right? And then 3 this way. So say it's about 3 units along the x-axis. And then connect with a straight line that looks like this pretty much. Now remember that this is 3. And that is still equal to 1. When y is equal to 2t, so x is equal to 3t, which is what we have down here. In other words, this is x equals 3t. Then when you divide one by the other, then you have that y divided by x is equal to 2 divided by 3, because the t's would cancel, which of course then tells us that y is equal to, so 2/3 of x. Where is that 2/3 coming from? Well, if you think about it, the 3 that you see in the denominator in the bottom, well, that's really coming from here, isn't it? It's the way that x changes versus t. So what we could do as a result is we could just make a copy of this and then place it along the horizontal axis here, so that's 3. And then take this and place a copy of that along the vertical axis, and then just translate it over here. So what I've just drawn there is the following. Let me emphasize it. Make this green, okay? So you see how this is 2 units along the y-axis? I just made a copy, translated over to here, just like I made a copy of this 3 along the x-axis, translated over to the x-axis. And now within there, you can draw a new line that looks like this. And now this line can be represented as this y is equal to 2/3 of x. And by using this process, we can understand where the 2 comes from, where the 3 comes from, and then we can imagine easily extending this to other examples where we don't have just straight lines, but we have a bit of curvature. And we would arrive essentially then at the slope of the line within the y-x plane using similar reasoning. But I'll leave it here. Again, if you're into more abstract, non-routine, or inventive math videos, sometimes though I do post straight up math, like for example, Putnam questions or a proof here and there. Please be sure to subscribe and like.